Okay, this is Dr. Williamson going to go over the experiment 5, determination of the formula of a compound lab. And the first thing we have to do is make a solution that is 0.1 molarity in copper 2 plus. Want 100 mils of that, it's 0.1 molar copper 2 plus. The salt that we have is copper 2 chloride, 2 waters, with a formula weight of 170.48 grams per mole. And we want it to be 0.1 molar in copper 2 plus. How do we do that? Well, for every one of these, for every 1 mole of this, I will have 1 mole of copper 2 plus because it's 1 to 1. So if I make this thing 0.1 molar in the entire salt, it will be 0.1 molarity in the copper 2 plus ion also. That's because this is made out of copper 2 plus, 2 separate chlorides, and 2 water molecules. So for every one of these, I will get one of those. So how do I make it? 0.1 molar. Well, I have a 100 milliliter volumetric flask, which is 0.10000 liters. And I want it to be 0.1 moles per liter. And the molar mass is 170.48 grams per mole. So I'm going to weigh out 0.17048 grams. I'm going to put that into the volumetric flask, and I'm going to slowly add water with mixing until the water reaches that line, right? And then I'm going to stir it up. Okay. Now let me erase some of this and kind of clean up this stuff here. Get rid of that mess. Let me get rid of, let me go back to draw. Now the next thing I'm going to do is I want a beaker. Where's my mouse? Where's my pointer? Okay, yeah. I want a beaker, here's my mouse, that has 20 milliliters of this copper 2 plus in the beaker. So what I do is I get a pipette and I suck up into the pipette 20 mils of this stuff, actually in excess of 20 mils. And I suck it up until the bottom of the meniscus is at the 0 line. And then I dribble it out until it falls down to the 20 line. And that means the amount of stuff that dribbles out here, that falls out here, is going to be 20 milliliters. 20 mils of stuff, this right here. And where does that fall out from? That's this stuff right here. So the amount that's dispensed will be the final volume minus the initial volume. And so it'll be 20 minus 0, be 20 mils. If I went 1 milliliter to 21 milliliters, it would be 21 minus 1 would be 20. So that's this right here. Okay. Then I started titrating this with the sodium hydroxide that's in the burette. I start my burette at 0 milliliters, and then I go at a rate of 1 drop per second. This is swirling when doing it at a rate of 1 drop per second. And then let's say I find my endpoint is right at 30 milliliters. So that shut off my purette. Okay. And my endpoint is at 30 milliliters. That's when it changes color. Let's go back over here to this table. The formula weight of the copper salt was 170.48 grams. That's how much let me type that back. CuCl2. That's how much that stuff weighed per mole. Based on these calculations, how much of it did I weigh out? 0.17048 grams. I put it into that volumetric flask. How much of it did I prepare? 0.1 liters, because it's a 100 ml volumetric flask. What's the initial volume of the copper 2 plus solution in the pipette? 0 mils, because that's its initial volume, right? That's where the line is at before I start dribbling anything out. What's the final volume? 20, because I dribbled it from 0 to 20, right? So that's, I dribbled out 20 mils into my beaker. What was the initial volume in the burette before I started dribbling anything out? It was at the 0 milliliters mark. What's the final volume when I reach the end point? 30 mils, because I'm just hypothetically saying that. Okay. Does that make sense, guys? All right. Now, let's keep going. Concentration of the copper 2 plus solution. People are asking me, what's the concentration of the copper 2 plus solution? Well, we just said that we were making it to be 0.1 molar. So it is going to be, you made it, and you calculated the amount needed to make it 0.1 molarity. How much did you add from the pipette? 20 mils minus 0 mils. That'll be, you added 20 mils from the pipette. Volume of sodium hydroxide added from the burette. Volume from the burette, volume, right, of NaOH dispensed. Remember, I'm an engineer, I can't spell. Equals V final minus V initial is going to equal 30 mils minus 0 mils will be equal to, oops, not 300. Okay, so in this example problem, it's 30 mils. Okay, so 30 mils. How many moles of copper 2 plus are down in here? How many moles of copper 2 plus are down in there? I'm going to erase this stuff because I need some space. So let's get rid of this. I hope I don't regret this. Okay. Molarity is moles over liters. So the moles will be the molarity times the liters. The molarity, I'm going to type this. The molarity will be 0.1000 molarity times the liters, right? Now we're talking about the moles of copper 2 plus. Well, right, the molarity is 0.1000 molarity. The volume from the pipette is 20 mils, right? 20 mils divided by 1,000 to convert it into liters is 0.02000 liters. And that will give me 0.002 moles. Of copper 2+. Similarly, well, that'll be 0.00200 moles of copper 2+. How many moles of sodium hydroxide were added? I'll do that in a different color, right? Just so we have a different color. The moles of the sodium hydroxide, NaOH, will be equal to the molarity times liters. And that molarity was 0.1001 molarity. That was written on the bottle for you by the stockroom. And what was the volume? It's 30 milliliters. The 30 milliliters is right over here, 30 milliliters. We got to turn that into liters. So 30 divided by 1,000 be 0.03000 liters. When I multiply those times 0.1001, it means 0.003003 moles. So it'll give me here 0.003003 moles. What's my mole ratio of moles of OH, moles of 2+? The mole ratio will be equal to 0.003003 moles of OH minus divided by 0.00000. Is that right? Moles of copper 2+, and that'll give me 1.5. That'll give me here, in my example, 1.5. And so if I do it right, I should get an average mole ratio of 1.5. That's if I do everything exactly perfectly right. Now, remember what I said, the proposed formula will not be Cu1OH 1.5. It will not be that. And it will not be CuOH 2, which the Tower method and everything we've taught you in class so far tells you it should be. For reasons that I'm not going to go into right now, the formula should be, okay, and you're just going to believe me for now. The formula should be Cu2OH 3. Okay. So I hope that helps. I walked through the calculations. Trials 2 and 3 will be the same. And I hope that helps, guys. Okay. And these are just sample numbers. All right. Bye.